Good evening. Thank you for coming tonight. We really are grateful that you are interested in supporting the series. Tonight is all about water. If you were here, the first one was all about heat, so water everywhere. What's happening with the Florida current? Is it slowing down? And what impacts does that pose for South Florida? How will rainfall, hurricanes, increased days of flooding dictate how adaptation strategies evolve? So that's what we're going to talk about tonight, and there's a lot to cover. So as you know, these types of events don't happen without the support of dedicated donors. So I would really like to take a moment to thank our Café sponsors, Bill Galway, who has been a friend and a supporter of our school for the past 8 years. He's sponsoring our Sea Secrets, which many of you asked me about tonight. That'll kick off in January of 2024. So Bill, thank you again for your friendship and support. Special thank to Polestar, a new age of electric vehicle, our corporate sponsor of the Climate Café series, a fan of the electric cars. Thank you, Polestar. So without further delay, let's get going here. Our moderator tonight again is none other than South Florida's finest, one of the finest environmental reporters, WLRN's award-winning journalist, Jenny Staletovich. Come on up, Jenny. Be sure to listen to Jenny's podcast that's dropping November 15th on WLRN, all about the Everglades. Next, please welcome Lisa Beal. Lisa is a professor of oceanography in the Ocean Sciences Department. She's got a big fan base. Dr. Beal is an expert on western boundary currents, such as the Agulha system of currents around South Africa, and she has brought recognition to the key role that these systems play in warming climate through her publications and international leadership. Her PhD student, Paloma Cartwright, doctoral student in ocean sciences and a member of the Beal Lab. Paloma, her studies are focused primarily on the Florida current and sea level rise in Miami and the Bahamas. Please welcome Dr. Katharine Mach, professor and chair of the Department of Environmental Science and Policy at the Rosenstiel School and a faculty scholar at the Abbas Center. Dr. Mach's research assesses climate change risks and response options to address increased flooding, extreme heat, wildfire, and other hazards. Tom Frazer, our visiting scientist who's a professor and dean of the College of Marine Science at the University of South Florida, where he also is the executive director of the Florida Flood Hub, which you'll learn about tonight, for applied research and innovation. Special thanks to Carolina Maran. Come on up, Carolina. She's our district resiliency officer for South Florida Water Management District. We will have time for questions. Jenny will run the Q&A. We just ask that you keep your question really focused on what we're talking about tonight. Thank you.
Thank you again for coming. I'm just going to refer quickly to a couple of slides that Brian McNulty provided to give us an overview of flooding and the sea rise that we're experiencing. I think it's worth noting that this year we are on pace to set a new annual record for sea level rise. As he notes, get ahead of me a little bit. There were 37 new daily records for high tide this year. So we are on pace to continue facing some significant flooding. So first, let's go to Lisa Beal, who is an expert in ocean currents. Ocean currents is something that fascinates me, and it has an effect on sea level rise. So take it away.
Okay, thank you, Jenny. Yeah, I'm thrilled to be here, and where do I begin about ocean currents, really? But ocean currents, to me, they connect Miami with the globe and global climate, and particularly the Gulf Stream, which is one of the world's most renowned currents in the ocean because it carries a lot of heat. And it also carries a lot of carbon, a lot of nutrients. So it's really plugged in a big way to how our climate is and how it's going to be. And so those are the big questions that I think about when I look at these currents. And in particular, here in Miami, of course, we think about sea level. And ocean circulation is also plugged into sea level. So when the ocean circulates, it circulates with the same physics as the atmosphere, but it's a much more dense fluid. And so just as in the atmosphere, we expect winds around pressure systems, we have currents around pressure systems in the ocean. which means that the sea level is not flat across the Gulf Stream. In fact, the sea level is about 1 meter higher in the Bahamas than it is here off Miami. 1 meter of sea level change across 100 kilometers is a huge signal. And our understanding of that is not new. This is something, I read about years ago in my oceanography textbooks. But what we don't understand really is the variability in how that sea level changes depending on what's going on in the ocean, depending on how much heat the ocean is carrying, depending on how much volume of water it's carrying past our doorstep. How many of you knew that the Gulf Stream, let's think about how big the Gulf Stream is compared to, in terms of its power, compared to the Turkey Point nuclear reactor, okay? A man-made phenomenon, right? It delivers about 800 megawatts of power. The Gulf Stream delivers about 1 million times more energy than that. So 1 petawatt of heat every moment is streaming by our doorstep and off into the North Atlantic, and it's affecting mid-latitude storm tracks. It's affecting rainfall. We think it may affect future carbon drawdown by the ocean. The ocean has drawn down about 50% of the excess carbon that we have released as human beings since the beginning of the Industrial Revolution. 50% of carbon, that's a pretty good, you can think of it in a pragmatic way, I guess, that's a pretty good damper of the climate change that we're feeling. Of course, there are bad side effects in the ocean to that. And it also has drawn down about 90% of the excess heat from climate change. So the way I think about the ocean, if I was to sum it up, is I think about it as like a flywheel of the world's climate. It's a massive reservoir of carbon. It's a massive reservoir of heat. What's going to happen, to that carbon and the heat in the future? How is the ocean going to feed back on the atmosphere to shape our climate into the future? And that's the kind of things that I think about.
And specifically in South Florida, you're looking at changes in the current and how that affects sea level rise here. I've heard before that if the Gulf Stream is slowing down, we'll get more sea rise, but it sounds like it's not just slowing down. There's a lot of factors going into what the Gulf Stream, what currents do. So specifically, how are you trying to, I guess, better forecast changes in sea level rise connected to what happens to the current? Can you do that?
I don't know. I'll be honest, I don't know. But it has this direct link to sea level. And so you'll see on that graphic, you'll see the sloping sea level. But that's not the whole story. We know that actually the sea level is going to vary. The modes of variability we tend to call in science, that sea surface isn't really flat like that, right? That's the entry point that us ocean physicists think about. But actually, the variability is a lot more complex. And so what we're trying to figure out is how exactly is sea level right here that we measure on Virginia Key in our school? How exactly is that linked to what's going on out in the Straits? On timescales that we can measure, that Paloma and I are measuring, from 20 minutes to several years out. If we can understand that better, then we can understand whether this idea about the Gulf Stream weakening is indeed the kind of source, as you were saying earlier, as to why we're seeing more sea level rise here in Miami than globally. So globally, the sea level rise over the last 100 years has been, on average, 3 millimeters per year. We think that sea level is rising faster than it was, certainly appears to be rising faster than it was over the last 20 years especially. So it's accelerating. And here in South Florida, we see a sea level rise of about 4 millimeters per year on average. So, what's the source on top of the global rise that we're seeing? And that's the question. So that's what we're trying to figure out. Is the Florida current part of that? Is the fact that the Florida current is weakening and this sea surface slope is therefore weakening, is that giving some of the extra rise that we're seeing in Miami? So that's really what we're trying to figure out. And we can look at that sea level signal on all these different timescales. So we do hope to be able to say something. Say we have a flooding event in Miami, we'll be able to tell you what's been going on out in the Florida Straits during that flood event. So we'll know, is there a marine heat wave out there? Is there extra volume transport out there? Or is there a super weak volume transport out there?
And the more you gather that information, does that help in future forecasting?
I hope so.
If you
particularly
detect these signals out there, you can
Right.
say, okay, we might have more flooding with this high tide than,
Yeah, so that comes back to the flywheel concept, right, of ocean. So we know, and probably everybody here in Miami knows that, we have a king tide. Better watch out, might have flooding, right? The water is extra warm at the end of the summer. Better watch out, we're going to have more flooding. That's the thermospheric rise. But in addition to that, we have this circulation that adds on to that. And the circulation changes, they're things that, because the ocean has all this inertia, respond much more slowly, and therefore potentially have some information that we can look at to say, okay, maybe there's some heat coming from the loop current or from the subtropics offshore of the Bahamas. Maybe that's going to influence, and we'll have a particularly bad flood season. Right. So that would be the hope. I mean, a lot of oceanographers talk about trying to link weather and climate.
Right.
So us humans, we know how to predict weather pretty well, but only for a few days, right? I mean, and rainfall, even then, forget it, right? In Miami, is it going to rain today? But we have some models, and we can do some weather forecasting, and we know that the summer is going to be warmer than the winter, so we're pretty good at predicting what's going to happen seasonally. And then, with all this climate change science, we can tell you that 100 years from now, this planet is going to be a lot warmer, and the sea levels are going to be a lot higher. But in between those two things, this is what we're struggling with.
Well, so we talked a little bit about just how difficult gathering data from the ocean, kind of doing the science is. And Paloma, can you talk about the work that you're doing to try and, I see something over there that I think is what you're using to try and collect the data.
Yeah, so this summer the Beal lab went out on 2 different expeditions. We call them research cruises on the Walton Smith, which you guys could have seen from the dock in Salt. And we went on 2 week-long expeditions where we deployed what we call current pressure inverted echo-sounders. And so that's pictured on the screen. It's myself, my lab mate Rachel, and our mooring technicians who we can't do any of the science without. And this is one on the right that's taken out of its cage. And if you have any questions about it after, I'll be happy to talk to you about it. But basically, we deployed 9 of these in the Gulf Stream from Miami to the Bahamas. And they will measure a lot of very interesting data that will help us hopefully answer the questions that Lisa mentioned about everything that the Gulf Stream's doing. And so in simple terms, they send a ping every 10 minutes to the surface of the ocean. So they sit on the ocean floor, they send a ping to the surface, and then they record the time that it takes for that ping to reach the surface of the ocean and travel back down to the instrument. And that's what we call the round-trip travel time. And that information, that round-trip travel time, will tell us a lot about the heat content that's flowing past the instruments, the water mass.
So you lost me a little bit?
Okay, sorry.
So how does a ping traveling tell you about heat?
Well,
is there something about the heat that affects the time of the travel, or?
Yeah,
Okay.
So the heat of the water mass will affect the sound of speed in the water. So the amount of time that it takes and how that varies will tell us if the water's warmer or if it's cooler, and that will help us inform how heat content is related to sea level rise. So we're hoping that all of this data that we're gathering over the next 5 years These instruments stay out to sea. We deployed them in August. We'll go recover them in October. So we'll get a whole year with 2 hurricane seasons, which is really exciting. And we'll redeploy them next October. And we will hope to have a 5-year look by the end of the project of how the Gulf Stream varies. And that will be able to answer questions about all these changes. And
I'm sorry, and you're looking at both sides of the Gulf Stream, so here on the Florida side and the Bahama side, which is where you're from.
Yes. So for me, this project is really special because I was born and raised in the Bahamas. And in 2015, climate change changed my life as I knew it. My island got destroyed by a hurricane, and my family lost everything. And I think at 15, when that happened, that really kind of guided where I would want to go with my life and what I would want to study, and has led me to here on a project where I get to learn about how the ocean is impacting sea level rise and what that'll mean for my home and my future.
So is your family still in the Bahamas?
Yeah.
Did they rebuild, or are they still,
Yeah, I mean,
still on Long Island?
Still on Long Island. And it took, I would say, more than 5 years to get us back to where we were post-Hurricane Joaquin. And that was really jarring for me at 50, and I was still in high school. And, you know, I always joke that I remember before the hurricane being like, oh, I get like a couple days off from school, you know, it's a hurricane day. And then I didn't go back to school for 3 months because we, you know, didn't have anything. So it's really special to be a part of this project that's measuring sea level rise and will help us inform how that's going to impact people in Miami and in the Bahamas.
Thank you. And actually this, I think, leads in well to Katharine and your study of adaptation strategies and ways to find, you know, to mitigate against the damage, like do we stay, do we go, what's the best kind of strategy? So can you talk a little bit about your work and how you're trying to apply it here locally as well?
Yes, I think so. And thank you, Paloma, for sharing that. I feel like it's a reminder of just how personal and important the work you're doing is and the work that we all are doing. So thank you. My work is really focused on how we all adapt, recognizing that this challenge of getting ready for intensifying flooding involves actions by so many people throughout society. And so what this slide shows up here is basically when we recognize that the climate is unambiguously changing at the same time that societies are changing. What does this mean for how flood risk management is now a different challenge, a challenge of adapting and preparing under intensifying climate change? And so the first theme up here is we really have to recognize, exactly as Lisa and Paloma were describing, that flood risks are now changing. We can't just quantify how likely this building is to flood with water of some level of depth and be one and done and prepare for that. Instead, the seas are rising. Storms are intensifying more rapidly. Rainfall is happening more intensely. And the nature of those challenges are no longer just in circumstances of disasters. It's now the new normals, right? So what happens when your neighborhood is flooded on the high tide and your neighborhood is on septic, and now you just have sewage to some degree floating down the street? These are radically new challenges compared to how we have thought about managing flooding more in the context of disasters historically. I think the second big theme that I think about a lot is, you know, what's at stake? I think Paloma set this up so powerfully. Historically, we would think about, you know, do people survive the storm, and are their properties damaged? But exactly as Paloma described, the damages from flooding go way beyond that. Losing time in school is a classic one. Historically, did we consider that? No, but it's very, very real. What about if you can't drive to your job because it's now flooding on the high tide? That is happening in this county, even though we might not really realize it. This is about, you know, our ability to provide health care. Things that we never would have guessed really have to do with flood risk management are now really vital in this space. And then the last one is basically so many people are making decisions about how we adapt and prepare. Each one of us probably has our emergency kit for what we do in a hurricane. We might have sandbags. We might have thought about electricity supply in circumstances of disaster. But now it's not just what every single household is doing and what the Army Corps is doing and what South Florida Water Management District is doing and what the county is doing. But suddenly we realize that flooding is a transportation challenge. It's a healthcare challenge. Suddenly we realize that we have to coordinate across so many different levels and agencies of government. So this question of kind of how do we adapt and prepare is phenomenally complicated and non-trivial. Maybe I'll go to the next slide. And in a way, I think where we've defaulted historically is that we're taking actions that are easy. We are trying to elevate homes where we know that that helps. We're thinking about our evacuation strategies. But it is a much more profound challenge to think about how we will deal with climate change 2 decades or 4 decades or a century out. And also how the choices we are making now add up to open up pathways or, in some cases, close them off for future generations. And so I think when we think hard about adapting in a changing climate, it's really essential to say change is inevitable. We have a lot of tools in our toolkit, but what we choose to do is going to be all about priorities that go far beyond those toolkits. I could keep going through my slides, or should I cut it?
Well, oh no, you should go ahead and talk about this one.
Keep going. Okay, so we can take that previous slide and then say, how does this apply here in Miami-Dade? And Carolina will take us region-wide in her remarks in just a second. And basically what you see as you go from the left to the right across the bottom images there is that right now the most common type of flooding experienced in this county, probably all of us have experienced this in our front yard all the time, is flooding that happens when it rains. Under intensifying climate change, though, increasingly we have the yellow issue, flooding that's more about inundation, on tides, from groundwater. And really thinking about how we get from flooding that is, by many measures, the most intense in the country, in this county, right here and now, to a future where our challenges grow a lot steeper is really crucial. I think I will stop there because there are probably other angles we can go.
Yeah, and then we can come back, because one of the questions I have is like, how do you then get action on this? How do you get government to respond? How do you get rules put in place or policies set in place? But first we'll go to Tom Frazer, who's the director of the state's new flood hub. If you could tell us a little bit about what that is and the mission of it.
Would love to do that. I'm actually in the presence of a legend, Jenny, so I've always wanted to have a conversation with her, but it's been difficult. But anyways, so the Flood Hub is actually a really great thing for the state of Florida. It's actually called the Florida Flood Hub for Applied Research and Innovation, and it was established by the legislature a couple years ago to deal with these issues that Kate just pointed out. We have tremendous flooding issues, not just because of sea level rise, but because of changes in precipitation patterns, kind of our water conveyance systems. All of these things interact to cause a tremendous amount of problems with regard to flooding across the state. And there are a lot of people interested in working on these problems, local governments, counties, other municipalities, regulatory agencies or state agencies. And so, but it's difficult because not all of those efforts are coordinated. People aren't always dealing with the same data, et cetera, et cetera. So really what the Flood Hub is designed to do is to actually serve as a repository of all types of information related to flooding, whether it's related to sea level rise or precipitation, but also to help advance the science, right, to provide things like sea level rise projections that are standardized so everybody can use them, make that data readily accessible. But again, at the end of the day, what we want to be able to do is to make sure that people are using the data. We want to insert that science, right, those science-related products into the policy and management space. And so that's always been a passion of mine, right? How do you, in fact, take science and make it actionable? So that's really what we want to do in the Florida Flood Hub for Applied Research and Innovation. And I'll just tell you real quickly how it works, right? So as we've already said, there's all kinds of contributors to flooding. and one of them may be sea level rise and another one may be precipitation. But the Flood Hub actually has a number of working groups, and our first one was called the Sea Level Rise Working Group. It was comprised of some of the leading subject matter experts and scientists around the world, and they ask a very simple question, right? Are the data that we're currently using to look at sea level rise in Florida and project sea level rise, is it appropriate, right? And so we acquired the best data that are available, and those data are there's a federal task force report that deals specifically with sea level rise, and we took that data. We didn't create new data, right? But we ask a very simple question: are those data appropriate to characterize sea level rise for Florida? And the reason that we ask that, and if you actually look at this slide, go back one. If you look at this slide, and I mean everybody clearly understands that that's Florida, but when the federal task force looked at things, they regionalized data. And I'm not saying that that was right or that was wrong, but they essentially split Florida right down the middle, right? And so Florida was kind of grouped into a Northeast Gulf region and an Atlantic region. And as a consequence of that grouping, there were different sea level rise projections for the West Coast and the East Coast. And they also incorporated places like Louisiana. And so where there's a lot of vertical land motion or land subsidence in the northern Gulf. And so there was some differences in what the actual sea level rise projections might look like for Florida. So what we did is we looked at the entire state as one unit, right? And realized that the projections, depending on the time horizon, or regardless of the time horizon that you're looking at, 2040, 2070, or whatever, that they were remarkably uniform across the state. I understand, and Lisa pointed this out, that there are certainly specific differences due to a number of factors, but they were remarkably uniform, and they were very similar, in fact, or aligned quite well with the global averages, right, or the global projections. So which then led to another question, well, what does that mean, right? Does that mean that these regional impacts or regional processes that Lisa talked about, do they exist? Are they important? Or are the global models just failing to capture those, right, in a way that we need to be paying more attention to? So that's kind of the next step of the Sea Level Rise Working Group, to kind of start to look at some of these regional processes. They need to look at some of the other factors that contribute to sea level rise, vertical land motion, and things like that. So, and they're also going to provide a greater inventory of sea level rise projections at different time horizons with the appropriate measures of uncertainty surrounding them, so people can actually make informed decisions. So I'll go to 2 slides real quick and I'll be done with this so you can get your stuff back. But this is an example of the things that we do. These are sea level rise projections that are specific for Florida. They are for 3 different time horizons. They're all relative to 2000, but to 2040, 2015, 2070. And you can see that they are given in millimeters and inches in those columns, and for various sea level rise projections, low, intermediate, high, and high. And so, but people can use that information, obviously, for a number of planning purposes. And if you go to the next slide, then you can see for kind of each one of those sea level rise projections, or some people will refer to them as scenarios. That's an issue in of itself. But we can provide this information about how likely are you to exceed that particular projection. So it gives you some idea of the risk that you might want to take or be willing to accept if you're going to embark on a particular project. If you're going to build a bridge, if you're going to build a road, right? How concerned are you, for example, your utility infrastructure might be impacted by floodwaters or things like that. So I think I'll leave it there.
All right, and just one quick follow-up question. So then once you have these sea level rise projections, are those going to be incorporated into designs? For instance, if the Department of Transportation is building a bridge, do they use your projection? Do they use the Army Corps? Do they use NOAA? How are they required to use?
Again, so one of the things that's really important to note is, And this is the one thing I learned about kind of integrating science and policy, right, is I'm going to stick pretty hard to the science. You know, we're not a regulatory entity. We're not going to tell people what to do. But the state can certainly choose to adopt some of this information to help set standards, right? But that doesn't mean that everybody has to live by those standards, right? They can certainly be more conservative. There are lots of situations where people might tend to be more risk averse or less risk averse, but at least they have something that they can defend those decisions on and a reason for making the decision.
Okay. And then, so we'll go to Carolina because I want to leave time for questions. Carolina is the resilience chief at the South Florida Water Management District, which is doing a lot to deal with the increasing risk, both coastal and inland with precipitation. So I'll let you talk a little bit about the projects that you're working on.
Happy to talk about the work that we are doing there. So I'm going to bring you to a more higher, larger scale here. We are talking about the area all the way from Lake Okeechobee down here to Miami. We manage this entire area. We manage water levels in this entire area. And we are talking here about climate impacts, and the UN, United Nations, have a number that they publish saying that around 90% of climate-related impacts are water-related impacts. So we are really talking about how we want to be able to manage water in this entire region here under future evolving conditions. So this is a big task that we have as an agency. And not only that, but we do have a system. So as you know, we live in this place today because we built canals to drain water away and get some of the land dry so we can occupy, we can have agricultural business and living conditions here. Those canals, the infrastructure that allow us to do that was designed 7 years ago under very different conditions than we have today. As we improve the system, as we operate and maintain the systems, we need to make sure that we are doing in a way that we will continue to provide the services into the future. So this is a lot of the work that we do. And we can move, this is a big piece of what we do. I would think about this system as well, is the environmental part. We need to also ensure that the water that used to flow down to the Florida Bay continues to flow now more than ever, because we do have impacts from changing salinities, from changing ocean levels that go all the way to the environment, and that has a very strong connection to the water, to our water supplies, to our protection of communities. So a lot of the work that we do is also getting back some of this water flows that were altered when we built the system to allow us to use this space. So it's a big job. And I have one more slide there that I think it's interesting just to understand what does it mean managing water? So on the bottom left there, we have a very natural system. We can manage, and we do that. We have to maintain flows, water levels, and conditions that are allowing those ecological functions to continue to exist, to have the benefits that we have as a region. So we make sure to bring water as needed and to maintain the water balance in these natural areas on a 24/7 regime. We also, and we do that more naturally, of course. We have interventions on how we can bring water to those systems. We have conservation areas. We do have some waters that we hold water and move water to protect the environment. We also do that on very urban settings, on the areas that we built those canals. Those canals are there, very shallow, as you can see. The water here is one water. Everything is one water. Groundwater is shallow there underneath us. We have to maintain those canal levels high enough to allow us to keep the freshwater system in its place and not allow saltwater to move inland. That's a big mission that we have, that we always had, and we have even more now, making sure that the saltwater front is not moving inland, impacting water supply sources, our well fields, impacting the environmental areas that we have. So we do that by maintaining freshwater levels, so maintaining those canals levels high, especially during the dry season, and also manage them to not cause flooding to the communities in every wet event. So it's a very small balance that we have there. There is not a lot of room. We are flat in general here, so we are not talking about a lot of fluctuation, and we have to maintain those levels right during the entire time and under evolving conditions. So a lot of those conditions are changing, and our job is to model, to plan, to understand what interventions we need to do that, to adapt.
And it's complicated.
It's complicated.
It is, because you have these changing conditions, and you have a very old flood control system that was built to not service 9 million people, but way, way fewer, that has just been built up immensely. I mean, when you think about it, was dredged and put in the 40s, what South Florida looked like in the 40s and what it looks like now, and then you add sea rise and increasing precipitation. So there's a couple of things I know we've talked about before, and I've written about, that you're trying to do to sort of keep up, just in the sense of flooding, like the coastal pumps. The Water Management District has a plan. There is also the Army Corps' massive restudy of the whole system. And I should point out, the last time they did this kind of restudy, it led to environmental Everglades restoration. So my expectation is it is going to be long-term and billions of dollars spent to try and retrofit the system. But I'll let you explain.
You're very right. It's not a cheap job. And I like that we have this slide there, because it reinforces one thing. All the work that we have been doing so far, 20 years of work through ecosystem restoration, are contributing to build resilience to our region tremendously. There is significant benefits that we already can count with that are a result of ecosystem restoration, Everglades restoration through those years. One thing that we can think about is maintaining water levels. That really helps with land subsidence. We have different conditions here, so we were able to maintain water levels everywhere through a lot of the restoration efforts, and again, salinity conditions in general. But yes, we are planning, and you mentioned the Army Corps study, and the only two things I think when we think about planning. First is, we know 50 years ago, planners and engineers designed a system to give conditions to us, all of us, to develop this region, to live here. And they had a set of information available to them at the time, and they probably made the best available decisions to them. We are going back to the same system one more time, 70 years again, with way more information, a much, much harder job. Engineers today have a much, much, much harder job to understand everything they are planning, all the consequences to the communities, to the environment, to the system, and also accounting for those changing conditions. And the way we think of how we can do this planning under so much of this changing and uncertainty is really connecting, is really listening, is really looking. All available information needs to come. This is a big mission that we take on, and it's taken very seriously in terms of, okay, what do we need to know now as we plan for those future adaptation strategies? What are key factors that we cannot miss this time? How do we really plan for this with the best available information, with the best understanding of the conditions that we have, with the best science supporting all of that, and making decisions in terms of how we deal with those uncertainties. So this is a lot of the daily planning efforts that we do along with the Corps.
A lot, right? So we have time for questions. I don't want to rob you guys of your chance to ask questions. And I think, Deanna, do you? So that we can share. Let me see. And again, I'll just reiterate what Deanna said, to if you can ask specific questions and keep them brief, so we get more questions.
I guess three short ones, but one, I've seen the valves. Your map only went up to Okeechobee, and I've seen the valves north of Okeechobee, and the 5 million cows pooping in our watershed every day. I mean, the water is managed from way up there, above Okeechobee. I was just wondering about that. And the other is real quick. Is Maine going to have the climate of Virginia soon? And is England going to freeze?
Well, with regards to the area that we manage water, you're right. We go all the way from the headwaters of Kissimmee River. So the entire Kissimmee River also is managed by South Florida Water Management District. So we have a watershed that has a huge contribution to Lake Okeechobee. And this is, of course, taking into the consideration to all the planning efforts and the way we manage the system. So yes, you're right. That's a large portion of our area that was omitted on my map there.
I think that, but because we asked you to focus on flooding and coastal stuff down here, so that's probably my fault. Next.
Oh, we have a question over here.
Oh, sorry.
I'm curious, with regards to FP&L, it seems as though FP&L has known for quite some time that their canal cooling system has been causing problems, specifically with hypersaline contamination. What are we doing to mitigate that in the future? What measures have we put in place to protect us and to make sure that FP&L is a good citizen?
I'm going to save you guys because I'm not sure that anybody here can answer that question. I mean, chime in if you can, but I think FPL and the Nuclear Regulatory Commission and the State Department of Environmental Protection would be the agencies that kind of deal with those things. And there is a cleanup plan that Miami-Dade County has in place, which we should probably check in and see where things are on that. That would be my job.
There was one slide that was columnar, but looked like there was another slide that had a map that was showing, like this maybe, that's showing where this rising water is going to impact us. This is all about us down here. I mean, it's Miami-Dade. I mean, is this going to go to Homestead? Is it going to wipe out Coral Gables? Where is all this going as it goes up? In one of the slides, 17 inches.
Or trade mics.
I think we're there. Sorry about that. So, I mean, the fact of the matter is that sea levels are rising. They're going to continue to rise, right? The rate of that rise will depend on a lot of things, right? But primarily on temperature, right? Because temperature, again, has a large effect on the density of the water, right? As well as, so I mean, you're going to add, when you melt ice, for example, right? That you're going to contribute to the volume of the ocean. When you warm the air up and the water up, that water is going to expand. You're going to have, all other types of processes that affect, whether the land's moving up or down, that vertical land motion. So all of these things are going to contribute to sea level rise moving forward. And I guess, what these data allow us to do is to better understand with a greater degree of certainty what those specific sea levels are going to look like in 10 years from now, 20 years from now, in 50 years now, so we can make some pretty sound decisions about how we're going to adapt and mitigate to this hazard or this threat, right? And we don't have all of the resources in the world. I think everybody recognizes that our resources are limited, and we have to make decisions in what we prioritize and where we invest those dollars. And this type of information allows us to make better decisions, help prioritize what we do with the limited resources that we have. So,
And I think
if I can interject, Tom, also I think you were maybe thinking about more regionally, right? How do we know certain areas are going to... It's all about how far above sea level you currently are, basically. So, if you're on Coral Gable, if you're anywhere on the Coral Ridge, which there was a really nice picture of that earlier.
You can see it.
I can't remember whose slide it was. I think it was one of yours, Kathy. Anyway, there was one earlier that had... no, not that early.
Carolina's map of Lake O also showed the original.
Oh, yeah, maybe it was Carolina's, yeah. But, so somewhere like Coral, the oldest neighborhoods tend to be, no surprise, the ones that are on higher ground. So Coral Gables, Little Haiti, anywhere along that coral ridge is a little bit better off because they're, I don't know, some 23 feet above sea level, something like that. I'm looking at one of my fellow professors. 15 on average, okay. So that's the safest place you can be.
Well, and also, we should point out that, one of the big risks is storm surge from hurricanes. I did a project with the National Hurricane Center where the Hurricane Center retracked Irma as if it had come across Biscayne Bay instead of the Keys and what that storm surge would look like. And the storm surge went all the way up to the Everglades. I mean, it crossed lower Florida was under.
Hurricane Irma was, I was on the leadership here at Rosenstiel School at the time, and I got the phone calls every 12 hours, and it was scary because up to 24 hours before Irma, basically crossed along into the Gulf, it was positioned in a way to push water up Biscayne Bay, and there's nowhere else for that water to go, right? So if it gets pushed northward, then it's going to flood, first of all the lowest lying areas of Miami. But actually, the storm surge for Irma was going to be 15. It was 15 feet was the prediction on that if it hit in that way.
And the lower end of the county where there is no ridge, but below Cutler Ridge, it just flows right inland. There's nothing to stop it.
Right. So if you're near Miami River or Little River. Any of those places where there's natural, some of the natural flow that comes out of the Everglades, we don't even notice anymore because it's paved over. But anywhere where there was natural low-lying land and flow.
But I think that's why, not to freak everybody out, but that's why people get pretty excited about storm
if we
surge
don't
and
do
hurricane
anything,
risk.
that's if we don't do anything. But there is a lot of planning happening there. There is one slide that I didn't have the chance to talk that I like because there are many strategies that are being discussed on how can we reduce those impacts. I have two more, I think 2 or 3. This one. So yes, we are seeing those scenarios where we see inundation going all the way up, but we are thinking about maybe additional levees, flood walls, additional canals and drainage that we might need to add to the system, pumping water out, additional living shorelines, natural-based features that we have been talking about the benefits. How can we bring more of those? Can we bring green infrastructure throughout the system? Can we have a hybrid solution there? Can we elevate property? Where we elevate? Where do we build? Where do we move water away? Where do we learn how to live with the water? I think a lot of the planning that we're doing is that. And we will be advancing those strategies. So,
and that's part of not the Water Management District, but also this Army Corps big restudy.
Yes, certainly. Yeah, local governments, as I said there, it's a role for all those multiple agencies, local governments, counties, municipalities, Army Corps, water management districts, water control districts. We have compact, we have counties partnering to understand those issues together and plan for adaptation strategies. And we have universities doing the work that Kate is doing here so we can capture all the best possible information and we read exactly how we want to adapt to those flood conditions the right way.
And since I brought up hurricanes, there is the Back Bay study that the Army Corps is doing around Biscayne Bay to try and find a better way to deal with storm surge.
I just wanted to, Carolina said something I thought that was super important. It's, Lisa said, hey, ultimately it's, the elevation is going to be the issue with regard to how much sea level rise can you accept. But what Carolina said, the real problem is how do we live with the water, right? How do we live with the water? It's not just the sea level rise, but it's this threat of flooding, right? And how do we, absorb more frequent, more intense rainfall? How do we convey that water or move that water around on the landscape that allows us to kind of exist, right, and still go about our business? So there are two kinds of things that are going on at the same time.
And to complicate things even further, is that water can't do ecological damage. I think we have learned that lesson the hard way, that when we move water around, we need to make sure it's going to the right places at the right time and that it is clean.
Absolutely.
Or we can clean up the places to receive the water. So we don't need to worry about moving water away.
So do we have more questions? Oh.
Yeah, I've been on the climate sea level rise projection committees for the Southeast Florida Climate Compact. And we talk about all these different scenarios. Well, they are emission scenarios. Which one will we as a society and a global society choose to take? Will we take the best case by reducing emissions and saving a ton of money on resiliency, or will we take the worst one and be forced to evacuate? Those are kind of the endpoints in this discussion. So could you say something about what is the trade-off? How much is it relatively going to cost to cut emissions, which we actually save money doing, versus the alternative?
I mean, I think the clear understanding at this point is that it has to be an all of the above strategy at the same time that we are moving as rapidly as we can to decarbonize emissions. We need to be prepared for the climate that is already changing. And I think a lot of the space of adaptation has really evolved towards kind of thinking about adaptive pathways and recognizing that we've got the scenarios of sea level rise. How long does it take us to move towards these futures that Carolina was describing, and recognizing that we don't know exactly when we'll see another foot or 2 or 3 of sea level rise, but we will at some point. What does that look like in terms of being prepared at the same time that we reduce emissions and at the same time that we think about evolving our energy generation and transportation under a future with more flood risk too?
Hi, I think this is a question for Dr. Tom. I was curious about the effect of land-based urbanization, maybe on a scale of 1 to 10. Like in Fort Lauderdale, we see total tree loss, paving over absolutely everything, no curbs, no place for the water to go. On a scale of 1 to 10, how important is the urban land side in terms of sea level rise or flooding, things like that?
Yeah, I'm happy to answer it, but I think Carolina might be the best one to answer it. In the sense that I think land use is critically important in how we manage water and how we move water in the system, and how that affects flood risk. So if you're asking me exactly how important it is on a scale of 1 to 10, well, I think it makes a huge difference, right? In large part, and just look at kind of the general kind of Miami metropolitan area. I mean, we have a lot of impervious surfaces here, right? It's radically altered the amount of water that can be incorporated into the soil, into the groundwater system. And so it has to find its way quickly overland somewhere. And so it's caused a lot of problems, and as Carolina pointed out, they spent decades and decades trying to solve this very complicated problem.
I think, Catherine, yeah. I'd love to add a flip side of this coin. So exactly as Tom described, when you pave over, you intensify flood hazards, but you are also putting stuff in the path of harm if you have just paved over a floodplain. So we've had an NSF project going the last few years where we quantified across every community in the United States how much development, whether it's commercial or housing, is going into the floodplain versus outside the floodplain. This is kind of this question that John asked of, the choices we're making now have a lot of path dependency. Okay, so the breathtaking number is that over the last 2 decades, if we look at every single home across the entirety of the US that has gone into a floodplain as compared to being sited outside of the floodplain, a full 50% of the houses across the entirety of the US that have gone into the floodplain over the last 2 decades have gone into Florida floodplains. That makes our problem a lot harder to solve, and one where kind of these questions of like the adaptive pathways figure I put up there, how we choose to develop in the first place really has a lot of bearing on how we then adapt moving forward as well. And our choices around development now are definitely consequential, at the same time that our choices over the last many decades are also consequential.
Dr. Beal, did you want to add something?
Yeah, I want to add something.
I'll go to
this
this
is
question.
super interesting too. So, I wanted to kind of double down on the point that Dr. Van Leer made earlier. If you think about the slide that Tom showed about the scenarios or projections of sea level rise. I think it's a really important idea, right, to interject maybe in that slide exactly what John was saying, that most of the reason we don't know whether sea level rise is going to be a foot or a meter by the end of 2100 is that we don't know how much carbon dioxide we're going to continue to put in the atmosphere. And that's on us.
And I just want to follow up on something Katharine said too. When you talked about how much had been built in floodplains, and especially in Florida, we need to remember that Florida used to have growth management laws. We had a better system of managing growth that we got rid of in 2013. And I think that when you think about, what you can have an impact on doing and how their science is used, how we build is determined by laws and by regulations.
Yeah, and that's, that always worries me. I live on Miami Beach, which, may be a crazy place to live, but I live in a historic area. To me, it's important that we preserve and that we live in mixed neighborhoods where you can meet people from everywhere and every walk of life and every income level. But, I've noticed that Miami Beach is under threat after some of these changes in the law. And I'd be interested in hearing you guys. I shouldn't be asking the questions, but how do we bring developers who have a very short-term scenario in mind of making their money, selling the units and being gone, and not thinking about how all of us in the city, after it's built, are going to support that into the future. How is that going to be? That's going to have to become part of our plan, right?
I could give a quick answer based on this same NSF grant, and then I think Carolina might have a response as well. What we are seeing, we're basically saying which communities are choosing proactive, climate-forward development strategies that avoid the future problems by developing smartly in the first place. And kind of the surprising thing is it's not so much about how wealthy the jurisdiction is, how many people it has on staff, how many policies it's putting into play. It is really about having a few policies that really work. And that is actually hopeful in that we don't need to do absolutely everything in the space of land use management and planning, but we need to be really strategic and effective in choosing a few policies and enforcing them through the whole course of the development cycle.
We have a question up here, and I want to be mindful of everybody's time. It's a great discussion. We're at a little after 5, so I'll leave it to the panel to decide if they want to go a little further, but this gentleman's been waiting here.
Awesome. Thank you so much. Great panel. I'm Silvio Pupo, local instigator for climate action. Been doing impact investing for some time here on the board of Master of Sustainable Business Program. Also leading the environmental finance and risk management program at the Institute of Environment at FIU. And my question around this, as somebody that's not really a scientist, but more of a technologist and financier, is I'm trying to understand what you're doing in the data hub, right? And I think where the rubber meets the road, obviously, is kind of this saying, hey, I'm only a scientist or I'm only a policy is important when you're in that role. But folks like myself that are a little bit independent, I think we have to mesh those roles. We have to be like, I'm a scientist, citizen scientist. I'm a policy driver. I'm a resident, I'm an investor. How do we sort of combine these things? And I think that to the gentleman in the South Florida Climate Compact, that would be my kind of ask of him or to him, is to try to really catalyze these folks so that the folks that are in corners can come together. And I think that's the goal of the Flood Hub. There was one slide here that was skipped over that I didn't get a chance to see, which is how the hydrological models are coordinating and how the data is being coordinated across those models. Because one of the things that I think is difficult to quantify and to show is, one thing is the fluvial, pluvial, and coastal. So the hydraulic, hydrologic, and ocean circulation models, and how you kind of combine them and harmonize them with enough physics to not double account, because it's not really linear in terms of how you use that data, aggregate that data, which is the first part of, I guess, the question, how are you doing that? And the second part of the question is, okay, how can, I guess, more plebeian, normal folk like myself visualize that, interact with that, access that in a way that doesn't require that I have a PhD or a data science degree or Python background, but that I can just click and point. And I think you might have also been using augmented reality or virtual reality for those efforts. So On the science, technically, how are you like helping to account, compiling the accounts and collaborating so others like myself can maybe access and contribute? And then how do we help synthesize these ideas and this data to the general public? Thanks.
Yeah, well, there's a lot in that. So what I would say, though, is you hit on all these very important things, right? And we tend to have these scientific work groups, right, that are dealing with a particular hazard or a particular component of flooding, whether it's sea level rise, rainfall, could be groundwater levels. You know, there are other elements like high tide flooding events that are slightly different than just the longer term projections, storm surge, which is more probabilistic. But at some point you have to tie all of these things together, right? Because you have to evaluate what the combined risk is, you know, and all those things affect what we call compound flooding. And we work, for example, with engineers in the water management districts who are, you know, they've developed their, you know, H&H models. They have data that they rely on, rainfall data that may be specific to their district, et cetera. But one of our goals is to be able to acquire that type of information, provide it, and provide not only the data, because in many cases some of the agencies or the districts have a lot of data, but think about how you stitch it all together in creative ways. So that's one of our roles, I think, in the Flood Hub. But a super important one, as you talked about, was how do you visualize that, right? And how do people fully evaluate that information? So, you know, right now we're in the process of, the Flood Hub is housed in the College of Marine Science at the University of South Florida, but, you know, we're building a facility there that will allow us to build out a fairly state-of-the-art visualization center that's not just for scientists, right? It's for our you know, county commissioners, our city commissioners, and folks can come in and look at the data. So it helps them think about the types of decisions they need to make moving forward. So I get where you're coming from, and it's not just the physics either, right? It's, you know, are we able to inventory all of the assets that might be affected by these hazards, you know? And so we will be working with economists as well, and ultimately we have to explain in no uncertain terms, you know, what does uncertainty mean, you know, and how do we grapple with that? That's a hard thing, not only for scientists, but just for regular people out there, and to make that, when we say something like that, make it more meaningful to them. So a lot on our plate, but I'd love to chat with you. I might hire you.
I don't know if you want to respond too, Katharine, because I feel like you do a lot of that work, like that visualization, at least the things that I've seen that you've done. I was like, oh, okay, now I get it.
And I'm sure Carolina has a lot to say about it too, but I realize we're getting a little late here. So yeah, this is something we've been thinking about a lot. If you want to know what is the flood risk at your home, what is the flood risk at your home if your neighborhood makes certain investments, what is the flood risk at your home if SFWMD makes certain investments, you have a few options. You can look at sea level rise viewers, or you can look at the First Street Foundation, which is kind of a very coarse model that doesn't really work in an urbanized region. So if you live in a very rural part of the state, that might work. But otherwise, it is incredibly hard, as Sylvia was describing, for anyone to get good data where they can do that what if exploratory thinking, build their intuition, and know what they want to advocate for. And so there's a new class of flood models that is not a class of flood models where it is accurate enough that you would go break ground and pour concrete, but it is accurate enough and rapid enough and interactive enough that you can start to ask those what if questions. And so that's something we've been really interested in. If you take kind of the technical pillar of a more interactive flood modeling capacity and embed that in adaptation planning, how does the whole thing change? Does it make it easier to resolve conflicts and have a better sense of how well different investments would work?
Yeah, and this is really one of the biggest challenges we have here in Florida today. We have a very unique system. We have a porous system, groundwater, surface water connected, ocean water and tidal influences, and we don't have one modeling age like a hydraulic, hydrodynamic model that can give us the right answer in the speed that we need to be able to evaluate alternatives. And we are investing on that. A lot of we are partnering with Tom. We are writing literally now a proposal in partnership with the Army Corps to be able to look at that, to understand how we can fully represent Florida. Florida is unique. Florida is unique on the rainfall. We see, we also have another partnership on the rainfall side to get the rainfall right, because all the global climate models that were developed have considerations that don't apply for the way rainfall, for instance, occurs in Florida. So we have a lot of unique conditions here, and we need a lot of specific model to be able to don't double count for some of those risks and fully characterize and play. We still have uncertainty, but in a little bit, I would say, more comfortable way.
All right, well, thank you. Any more questions? We'll get one more. Okay, one more in the back there. You shot your hand
Ryan,
up first. That
go
was
ahead.
who
Give her
I
the-
saw.
Yes, please, so we capture it for video.
Right there.
Ryan,
yeah,
right next, there you go.
Yeah. Oh. And I'm sorry, I'm keeping everybody longer, so keep it. Okay.
Hello? Okay, so just some pretext. So Miami Beach used to be a mangrove barrier island. I'm sure you guys are aware of that. And so Miami Beach currently is experiencing a lot of king tide floods and rainfall floods. And my question is, given the fact that it's an artificial island, why hasn't Miami-Dade as a city retreated from Miami Beach instead of using pump systems that are not even supposed to be there, and also like dune restoration, which is artificial dunes that were never even there in the first place? So I think it creates like a false sense of I guess, saving Miami Beach. And the point is I don't think there's enough people that realize that some land areas are not able to be saved. And so I wonder how that information is being used in the city as a whole, and how are we translating that to landowners? Because I know that there's a lot of pushback with retreat options. So that's my question.
Retreat, me, for better or worse, I can definitely talk on this topic. Can we go back to the adaptive pathways slide? I mean, I think in a way, Carolina and Tom said it best, that it's really a challenge of figuring out how we're going to live with a lot more water in the system. And I think people tend to go between two extremes here. So number one, let's build a wall. Awesome. We'll keep all the water out. There are places like Manhattan where financially that will definitely pan out and be what happens. In more rural areas, that wall solution is really, really hard to imagine how we're going to fund that sort of protection across the US. So failing the wall idea, people usually then go immediately to throw up our hands and retreat. Okay, but the good news is between walled and a major consolidated retreat scenario, there are many, many possible futures where we think about making room for blueways, water in the urban environment, where we think about pairing elevation, where we think about profoundly different ways of living with water. And I think this is a place where this is not hypothetical. This type of thinking is very, very real, but I think really one where we have to recognize that there is a ton we can do, even though it'll be a world with a lot more water.
And Lisa, I'm going to ask you to chime in because you live there and you have this connection, and you talked about like it's a place with a history.
Yeah. No, I mean, thank you. It's a really great point, right? I mean, there are other places where people have, why do people still want to live in New Orleans? That's below sea level, So it's complicated. People get emotionally attached to their neighborhoods, etc. But one of the things I would say that did come to mind, when people think about Miami Beach as being on the front line, right? But actually in Miami-Dade County, Miami Beach is not the place that floods the most, and it's not the most low-lying, right? There are places in Doral that in rainfall, or they literally have salt water bubbling up into the street when there's when there's king tides. So if we're talking about retreat at Miami Beach, we're talking about retreat of, a lot of places in the county. And I know on the individual level, we've just been reading in the press lately with the current elections and so on, New Jersey is also dealing with a lot of water. And I know they have buyback programs, and I saw that was one of the scenarios you were talking about. So I guess it's not I guess that's in a way as a retreat, right? You're no longer going to support that person living there in that house. I think when it becomes 100,000 people, a lot more complicated.
Very expensive.
All right, well, thank you guys very much. I thought this was great, and I really appreciate your time.